Welcome back, everyone. Today we'll be solving LeetCode 103, binary tree zigzag level order traversal. So if you haven't seen my binary tree level order traversal video already, watch that first and then come to this problem, okay? So given the root of a binary tree, return the zigzag level order traversal of its nodes values. So example, from left to right, and then right to left, and for the next level, you go back left to right, okay? So don't let the question confuse you. Let's look at these examples here. Notice how at level 0, we just have the node 3, and then at level 1, notice how we're flipped, right? We have 20 and 9, and then at level 2, we're back normally left to right. So I'll just consider, we'll say at the odd levels, we're gonna just reverse the level when we append to our output array. It'll make more sense when I go to the drawing board, okay? So when we look at example 2, it's just one node, right? So we just return that one node. And notice how there's no nodes here, so we return empty, which is a good transition because in your interviews, right, you have to ask for edge cases and constraints because the number of nodes in the tree can be of size 0, so that's an edge case. If there's not a root node, just return empty lists, okay? Everything else here is pretty straightforward. When we look at the drawing board, we'll treat level 0 as even, okay? So the output of this will be, we'll have, so the output, all right, at level 0, it'll just look as expected normally, right? And then at level 1, we actually flip, right? We reverse. So that's level 1. And then at level 2, we're back to normal, right? And look at the indices of this array. I could maybe even say levels too. Notice how they match here, right? Okay. All right. With that being said, the approach we're going to use is we're going to use a queue. And we're going to do a breadth first search, but we're gonna level it, right? We're gonna do a for loop inside of the queue. So let's draw out the function signature so you have a better understanding of my approach, okay? So essentially, what we're gonna say here, right, is we're gonna define this function. We'll say define zigzag level order, and it's going to take in a root, right? Okay, and remember what I said earlier, right? We have to consider the edge cases. So don't trip yourself up during an interview, ask for edge cases. So we'll say if, let's use a smaller font here. Okay, so we'll go here. All right, so if there's not a root, we can just immediately return an empty list, right? Otherwise, let's create our res list that will return at the end when we populate it, and we'll need a level variable to keep track of the levels that we're currently at, right? Okay. And as far as the data structure we'll use, I like to use a Deque to represent my queues because I can insert left, right, O one time, I can pop from the left or the right O one time. So I just use it in general. I just use a Deque, okay? So we'll say Q is equal to collections Deque here. And of course, we're gonna start off by putting the root node, right, inside of our queue. Okay, so let's go ahead and illustrate that too. Let's represent our queue. So I'll say Q is this here. And in this current moment, it has the root node. And let me label that as well. So I'll say, this is the root, okay? So I'm gonna take this guy, put it in our queue, okay? So then, while there is a queue, and there is, right? Look at the size, it's size 1. So while queue, that means we have work to do, right? Let's retrieve what we have in our queue. But before we do that, let's keep track of the current nodes and the level. So I'll create this here. And let's also represent that visually so we know exactly what's going on here, okay? It's nice to encode our brain visually with what's happening, okay? So let's use this color here. So we'll say cur level. It's empty for now. Okay. All right, great. So iterating through our queue, right? So for underscore and range length of our queue, we say the current node is equal to queue pop from the left, right? Cool. So in this case, this is our queue, and we just pop this off. So this has been popped off, right? Cool. And we're going to append its value. So we'll say cur level dot append the cur node's value, right? Not the cur node, the cur node's value, because we're going to return a list of integers, okay? That's the data type we'll be returning. All right, cool. So this guy right here, see if I can extract that. Okay, cool, I did, nice. All right, so cur level has this value 3 inside of it, okay? And let's check if it has children, okay? Does this node here have children? Yes, it has a left child and a right child. So let's process them, okay? So we'll ask ourselves, if cur node dot left, we're gonna give it to the queue. Queue dot append cur node dot left. All right, okay. And let's make this diagram a little bit smaller because I don't want the bottom of this page to crop out, okay? All right, so that's looking pretty good there. Okay, cool. All right, so we just said, does it have a left child? It does, so we're gonna append it to the queue, okay? So here's the left child, queue. And then if it has a right child, so if cur node has a right child, we're gonna also append that to our queue. All right, so this guy is the right child, append it to the queue, great. Okay, so now let's address this level, right? So we need to know what level we're at so we can zigzag, okay? And by zigzag, we'll just reverse the list, right? So at this point, we're gonna ask ourselves, and make sure you write this at this indentation layer, okay? Do not write inside of the for loop, okay? It'll be a pain and it'll be the wrong approach, okay? So we say if the level mod 2 is not equal to 0, all this means is if we calculate the level by modding it by 2, whatever this result, if it doesn't equal 0, that means we're at an odd level, okay? So if we're at an odd level, we're gonna append, so we're gonna append to a result array, the cur level, right? This cur level here, which looks like this, okay? We're gonna append to that. We're gonna append to the res the cur level, but reversed. And that's the first part of the zigzag pattern, right? Okay, otherwise, so we'll just say else, that means we're at an even level, right? So we'll just append to res the cur level without reversing it, okay? Just like that. All right, cool. And finally, when we move on to this next level, which we'll be doing when we get back inside this queue, we need to increment this variable to match the succeeding level. So it's very simple, right? We just say level at this indentation layer. Remember, we have to stay here. Level simply plus equals 1, okay? And finally, we'll be returning our resulting array, okay? This is a lot of code, so bear with me here. Let's, maybe I can make everything a little bit smaller. Yeah, let's try that. Okay. Just follow along, it's fine, okay. So the level, right? So if you remember correctly, right? We finished this, that's why we have a 9 and a 20, the left and the right. So the left and the right. If level mod 2 is not equal to 0, res.append the cur level. So we did not hit that step. We hit this step. So res now, let's create that as well. So res, so we can visually see that. What color? Let's use this color. Okay, so res now looks like this with the cur level, right? So I'll just drag that up. Maybe that will be clearer for you guys. So this guy is inside of a res now. And then we say level plus equals 1, okay? So level now goes from 0 2, 1. Okay. And maybe I can bring this up a little bit higher so it's not cut off from the frame, and this as well. Much better. Okay, great. So level plus equals 1, I just did that. Okay, so are we back inside this while loop? Yes, because look at the queue. It has 2 items in it that we need to process, okay? So cur level, look how we reset it to empty. So it's empty now. For underscore and range length of queue, cur node is equal to queue.pop left, okay? So we pop this guy, okay? And we and then we append its value, right? That 9 to cur level, nice. And then we ask ourselves, does it have a left child, right? Does this cur node 9 have a left child? It does not. Does it have a right child? It does not, right? It's pointing to none. Okay, so we're still inside this for loop though, right? So now we're gonna pop this guy off. We're gonna ask, well, before we ask, we're gonna append its value to the cur level, okay? And then we'll ask if it has a left and if it has a right. It does. It has 15 and it has 7. So let's grab those 2, put it to the queue, okay? And we're done with this for loop. So now we ask ourselves, is the level mod 2 not equal to 0? So 1 mod 2 is not equal to 0. That gives us 1. So this time we're gonna append to res the cur level but reversed. So we're gonna append this guy but reversed, okay? So it's gonna look like this, but reversed. So this guy here, okay? Great, and now we hit here. So level plus equals 1. Level is now equal to 2, okay? And are we back inside this while loop? Yes, we are, because look, we have 2 items here, okay? So pretty straightforward. We pop this guy off, okay? And we pop this guy off. Well, here, let's go through the approach, right? Well, when we pop off this 15, we ask, well, before we ask, we append its value to the cur level. And by the way, this is, I forgot to update this to be empty. So we're gonna append this 15 value here. So this is 15. We ask if it has a left child or a right. 15 does not point to anything. We're still inside this for loop, right? Because we still have this item here. We pop this guy off, okay? And we append its value 7 to the cur level, right? Just did that. Does it have a left or a right? Nope, it does not. All right, so we're done with this for loop. Is the level mod 2 not equal to 0? Well, 2 mod 2 is equal to 0. So we're gonna just append the res, the cur level as is, okay? All right, so we have 3 items inside this res, and technically the level 2 will increment, but we don't have to worry about that because we're essentially done. And then we just return this res, okay? So notice though how convenient this approach is, right? Look, this is index 0, 1, 2. And is that zigzag? Let's see. Well, at level 0, it's good. At level 1, it is zigzag. We have 20 and 9. At level 2, we zigzag again and we have 15 and 7. Cool. So with that being said, let's go over to LeetCode and let's code this solution. All right, so as I mentioned from the jump, right, if there's not a root, let's just return an empty list, okay? Otherwise, we say res is equal to an empty list, and we track our level, we get our queue. So I'll just paste that in. We get our queue, which we populate with our root, right? Because that's how we start our work. And then while queue, let's track the levels that we're at. So cur level first is empty, and then we iterate through. So for underscore and range len of our queue, cur node is equal to queue.pop from the left, okay? Cur level now, we append cur node.value, and then we ask ourselves, right? If cur node has a left child, we're gonna add it to the queue to process in the future, right? So cur node.left, okay? And if it has a right, so if cur node.right, we're gonna also add that to the queue, node dot, yeah, so cur node dot right. And then at this indentation level, if the level, sorry, at this indentation layer, I don't want to throw levels or a level around all the time. It might confuse you. So if this indentation layer that's at this for loop, right? If that level itself mod 2 not equal to 0, so if we're at an odd level, we're gonna append to our res the cur level though, but remember, reversed, okay? Otherwise, we are going to append to res the cur level as is, and then we need to update our level for the next tracker, the next processing, and then we're gonna return the res. All right, let's test this out. Hopefully no errors here. Oh, great, so it passed these initial test cases. If we submit this, wonderful, we get a working solution. Let's navigate back to the drawing board. Let's talk about the time and the space, okay? So the time will be big O of n, right? Where the variable n represents the size of this tree. In this case, it's 1, 2, 3, 4, 5, but it can vary, right? That's why it's a variable, okay? And then the space complexity. So the space is big O of n as well, right? Because eventually we'll be processing everything inside of this tree. So we're using O of n space. And with that being said, whatever platform that you're on, please like, comment, subscribe, and I'll see you in the next one.